Welcome to the first tutorial in this series of tutorials for Engineering 205. Today I'm going to demonstrate the basic concepts of chapters 2 and 3, such as KVL, KCL, and voltage and current divider circuits. I highly recommend, though, that you try to solve the problem by yourself, and then if you get stuck, you can continue watching the video. Note also that the solution I'm going to present is only one solution or one way. There are many other ways to do the problem. So let's begin. Consider the following circuit. We would like to find the voltages V and V1. V is the voltage across the 1.4 milliamp current source, and V1 is the voltage across the 4K resistor. Let's first add some currents to the figure as follows. The directions of these currents are arbitrary. I could have chosen them to be in the opposite direction. However, looking at the direction of the two current sources, it makes sense to choose I1 in this direction. Also, with this choice, I2 is in the direction of voltage drop with respect to V1 and the 4K resistor. Now, V1 can be found if I2 is known. From Ohm's law, we know that V1 is equal to 4K times I2, and K here is 10 to the 3. Let's add labels A and B for these two nodes, and let's write KCL equation for node A. Now notice that I1 is entering node A while the two current sources are leaving. So the equation can be written as follows. Minus I1 plus 0.4 V1 plus 1.4 is equal to 0, or I1 is equal to 1.4 plus 0.4 times V1. Keep in mind that the values of the two current sources are in milliamps. Okay, so far we have the following two equations. I have put milliamp at the end of the second equation to emphasize the units. What do we do now? Notice that I1 is the current resulting from the two current sources. Also, this current breaks into two parallel branches and is divided into two currents, I2 and I3. So here's a good place to use the current divider technique. Using current divider, we get the following two expressions for I2 and I3. For example, for I2, we multiply the current I1 by the resistance of the other branch, which is the 3K, and then we divide by the sum of the resistances of the two branches. And we can do the same to find I3. Okay, so far we have these equations 1 through 4, and these equations are enough to find I1, I2, I3, and V1. In fact, substituting equation 3 into 1 gives equation 5, which is V1 is equal to 4 over 3K times I1. And then substituting equation 5 into equation 2 gives I1 equals 1.4 plus 0.4 times 4 over 3K times I1, and then multiplied by 10 to the minus 3, and the 10 to the minus 3 is the milliamp thing. And then solving for I1 gives I1 equals to 3 milliamps. Now, using the value we just obtained for I1 into equations 2, 3, and 4 gives the following. V1 is equal to I1 minus 1.4 divided by 0.4, and this equals 4 volts. I2 is equal to 1 milliamp and I3 is equal to 2 milliamps. Great. So we have these values now for I1, I2, I3 and V1. Now in order to find the voltage V, we can do KVL on this left loop. Using KVL, we get the following expression: minus V plus 3K times I3 plus I1 times the sum of the two series resistances 1K and 2K. And finally, substituting for the values of I1 and I3 gives V equals to 15 volts. And that's the end of this example. Well done, and I'll see you in the next tutorial.